Well, hello everybody, and welcome again to another OpenShift Commons briefing. Today, with the advent and release of OpenShift 4.2, we've got a two-part series starting about what's new in OpenShift 4.2, and today's talk is on the platform services side of things, and in 2 weeks' time we will follow up with part 2 and do an update on what's new in the infrastructure side. So watch for that. It's either going to be November 6th or 7th. And today we have leading off Rob Sumsky, who's one of our product managers, and a couple of other folks too. And I'm going to let Rob introduce himself and the others, and we're going to get rock and rolling. We have about 45 minutes worth of content to share, and then we'll have live Q&A at the end. And feel free to ask questions in the chat while this is ongoing, and we'll try and stage them and stack them all up for the Q&A at the end. So take it away, Rob.
Thank you, Diane. Welcome, everybody. So I'm here with some of the other PMs from the OpenShift team, and we're going to talk you through the platform services roadmap and what came out in OpenShift 4.2. I'm joined by Ali and Daniel, who I'll let introduce themselves really quick, and then we'll get started.
Hey everyone, my name is Ali Mober. I'm one of the PMs on the OpenShift team. Super excited to be here today to tell you about all the great stuff we have for you.
And there's Daniel as well, also on the OpenShift product management team. I'm going to walk you through operators and pipelines today.
All right, with that, let's get started. So I wanted to cover just really quickly some of the themes in OpenShift 4. We're primarily going to concentrate on, these themes are very infrastructure focused because we did a lot of work on the core infrastructure to bring auto scaling out of the box, a new way of doing day 2 operations with our over-the-air upgrades, and this theme of both immutable infrastructure and automated operations. But we're going to kind of table that for another day and mostly talk about some of the operator framework and the things you see on the green box here, and how this helps us deliver new features and tools on top of the platform to provide services to your engineers and developers that are actually, launching applications, building new applications for your enterprise. The great thing about this is this theme of automated operations goes all the way through up and down the stack, and we want these platform services to have that same automated operations experience that you expect from the infrastructure. So if you picture like a cloud-like experience, you've got your compute nodes automatically upgrading as new kernel versions come out. You also want your Kubernetes to be upgraded as new security fixes come out, new enhancements come to that platform, as well as all the OpenShift tools that glue that together, that make OpenShift the most powerful way to run Kubernetes. And then, of course, you've got platform services on top, your logging stack, your monitoring stack, CI/CD workflows. You want all of that to stay up to date at the same time. And so what we want to do is bring that same experience all the way up and down through the platform. And some of the features we're going to talk about today fulfill those goals. So these are what we kind of think of as the main pillars that sit on top of the OpenShift core. You see there's a box here for platform services. That's primarily what we're going to focus on today, but you can see that this sits beside a number of our other different features that come outside the box of OpenShift to make it really easy to get up and going with an enterprise Kubernetes offering. The first thing I want to talk about is this idea of a connected customer. This is really exciting because this automated operations is only powerful if you've got a health of the fleet going. If we're going to push these over-the-air upgrades, we need to figure out what's going on across the fleet so we can make everybody's bugs fixed and everybody's clusters more powerful. So this is kind of core into everything that we're doing in OpenShift. So breaking down the platform services, you can see in this middle box here, they're labeled, and there's a number of capabilities and then technologies that power that. So for a container registry, we have Red Hat's Quay offering. For building, we have a productized version of Tecton. For doing serverless, we have a productized version of Knative called OpenShift Serverless. And this is the core of, we provide the best in breed out of box in our opinionated view of the most stable versions of all of these technologies. But of course, you can swap these out. We don't want you to feel like you have to stay glued to, if you want to go to Jenkins X instead of Tecton, totally great. There's a number of container registries, a bunch of ISV operators that we've partnered with for doing all kinds of storage and monitoring. So it's a really powerful way to get the best in breed, but also have as much choice as you would like. So I'm going to hand it over to Ali, and he's going to jump into the OpenShift console.
Awesome. Great job, Rob. Thank you so much. Can we go to the next slide? So today I'll be your Sherpa for the next couple of sections. First thing I want to talk about is the console, right? For the console, we actually did a number of enhancements for 4.2. I think that are fantastic. The first one I want to go over is the console customization. We built this using custom resource definitions, and there's several of them. So we have the console link CRD. This will allow you to come in and add items to the help menu, user menu, or our brand new application menu, or we sometimes call application launcher. That's a really nice resource for you to come in and really extend out the platform and to be able to customize it. The next item I want to talk about is our ability to add notification banners with the console notification CRD. The use case here really is if you want to call out that this is a production cluster, or you want to say this is a special type of cluster, especially if you're managing multiple clusters and going back and forth between different tabs, we definitely want to make sure you don't make some kind of mistake in updating the wrong production cluster. So we want to be able to give you the opportunity to label or put some type of informational message for your users at the top of the screen or the bottom of the screen, depending on your needs. After that, like always, we've always allowed people to come in and brand the console, giving the opportunity to change the logo and about page. Something new that we haven't had before is the ability to come in and add your own command lines. So out of the box, we're going to offer you the OC command line and ODO straight download right from the console. But if you want to come in and add your own command lines to that, you'll have the ability. So if you want to offer your users kubectl, you definitely could do that. Last but not least, we have external log links CRD. This will allow you to link to external logging solutions of your choice, say Datadog, Splunk, whatever you guys like. Can you go to the next slide, please? All right, so one of the reasons why we use the custom resource definitions to do this was this allows third parties to come in and programmatically update these things, right? So for example, let's imagine you guys come and install Couchbase Operator, and the Couchbase Operator has its own web console. We now allow them to automatically or programmatically come in and add a link to their web console through our application launcher menu at the top of the screen. For example, also if you want to install Knative or Serverless, there's a Knative command line. You could add that to the command line screen. So we really, when we came in and did the customization stuff, we were really thinking about how can we enable our users and our partners to come in and to extend the platform. So that's kind of the theme behind all this stuff. Really powerful, really cool, and in the future we'll continue to enhance this as well. Next slide, please. All right. The next thing I want to talk about is declarative UIs for operator back services, right? So one of the cool things here is before you install your operator, and then when you want to create a resource that the operator was managing, it would take you straight to YAML. Now, because there's Open API v3 schema required for each definition of each resource, we could go ahead and create you a generic form that will be used on the creation of that operand, right? So the nice thing about this is we create a linear form based off of the API schema. We could also do validation off of that. The bad part is it's going to be linear. It might not be the most user-friendly interface right out of the box. But we added another layer on top of this. We created something called OLM descriptors. And with OLM descriptors, you get a bunch of advanced widgets that come in. If you look on the picture on the right, you get a couple examples. For example, there is a password field there, right? You also get the ability to do image pull policy, update strategy. We have widgets for pod affinity. We have widgets for getting a list of your secrets available to you. So we're really coming in and trying to enhance this the ability for your user interfaces for your operators. We have also the ability to like do field groups and paging. So look for some really cool stuff here from ISV partners to come in and create. This will also be available to customers, right? So that's the great part about that. Also in the future, we're going to be providing a contribution guide. So if you have a widget of some advanced widget of some type that you don't see here, we're going to give you the ability to come and work with our design team and be able to contribute it back to the ecosystem. That's going to be really cool. Next slide, please. So the next thing I want to talk about is the API Explorer that we added. So one of our other items that we try to focus on when we build out the console is to help educate users. So with this API Explorer, we're kind of showing you all the APIs available on your cluster. We're showing you all the different versions available. Give you the ability to kind of like dig into that API. We have a schema tab that will actually allow you to see all the different fields and what they stand for. We have instances tab to show you how many instances are running on the cluster. And then we also have an access review tab, which will show you who has access and what type of access they have. So this is our initial attempt at this. We're actually going to be adding a lot more enhancements in 4.3 in this area as well. Again, we're trying to make it easier to understand what's happening on your cluster and adding full transparency and to help educate users here. Next slide, please. All right, so here's the overall console roadmap. We kind of went over all the stuff in 4.2. I'm going to talk a little bit about some of the highlights in 4.3. Look forward to tighter service mesh integration, also Quay integration. We'll be able to externally launch to both of those applications. We'll also be pulling in Quay vulnerability data straight into the console, so you can see which projects and pods and whatnot may have vulnerabilities on your system. Look for increased YAML examples. We're actually coming out with a new customization where users could upload their own examples for their users if they want. And then also look for the ability to open a support case straight from the console in 4.3. Further down the road, we're going to add some really cool stuff. We're going to add multi-cluster support. We're going to add a bevy of new dashboards to help you manage your users and quotas, and so forth. Next slide, please. All right, so the next thing I want to talk about is the OpenShift Dev Console. So the first thing about the Dev Console, it's actually the same console as the regular OpenShift console. If you look at the top left, there's a drop-down that says Developer. It's really more of a perspective. And we created this perspective specifically for developers, and we've abstracted away all the Kubernetes terminology and items to really allow developers that may not know as much about Kubernetes as possible to come in and not be intimidated. At the same time, we are exposing some Kubernetes items there as well. So we're trying to start educating users, developers that may not know too much about Kubernetes about it, but they get an opportunity to come and start learning about Kubernetes. So we've been talking to a lot of developers. The team that's been focused on this has done a great job. They've interviewed hundreds of developers to really try to focus on making the best product possible here. Next slide, please. All right, so some of the Dev Console roadmap highlights I'd like to go through. So 4.3, we're going to have the ability to do app linking binding. This is if you want to deploy your application and then all the relevant services that it depends on. We'll have that ability to do that. We're going to add some easy membership management. This means I'm a developer, I'm working on a project. I want to easily add other developers to this project without having to know all the difficulties of the Kubernetes RBAC or complications of the Kubernetes RBAC stuff. Last but not least, at the very bottom, we're going to be adding the support for Knative serverless grouping of revisions and eventing. And I'll talk about serverless stuff a little bit down the line. And then 4.4 plus, some really cool stuff we're going to be adding is app monitoring and metrics. We're going to add an advanced pipeline, Tecton pipeline editor. And then we're going to provide a full-blown functions as a service interface for all the developers out there. Next slide, please. All right, so jumping into OpenShift Serverless. First, I kind of want to give the overview of definition of serverless. Serverless is event-driven computing, right? On OpenShift, that means you can now scale your workloads down to 0, and it's trigger-based, right? If you look at this image here, we have in the infrastructure section, it's based off the top of OpenShift. We're using something called Knative. Knative will allow you to go ahead and serve up your workloads. One of the things that I want to talk about as well is previously serverless was equated to just functions. So like think AWS Lambda. That definition has grown and changed. Serverless now pertains to just all containers. So in that container, you have the ability to run a function, you have the ability to run a microservice, you have the ability to run a full-blown app, right? With Knative and OpenShift, you could go ahead and make any of those into a serverless application that's going to be event triggered and can scale down to 0. If you look on the left-hand side, we have a section that kind of lists out all the different event types. We're going to be providing interfaces into AWS, Azure, GCP to get triggers from there. But there's one below there, the picture of the camel. That one's going to be really important. That's Camel K. And what Camel K does is it allows you to interface with, I think they have 200 plus integrations out of the box. They're mainly focused on enterprise type of integrations. So I want you to think of like SAP, Salesforce, Workday, and so forth. And all these event triggers you'll be able to download them via operatorhub.io. Next slide, please. All right, so a little bit deeper dive into the OpenShift serverless. There's two areas here. There's actually 3 before. It used to be build, serving, and events. Build kind of went off on its own and became Tecton. We'll talk about that a little bit further down the line. But our main focus here is going to be on serving. Serving is made up of multiple components. So you have the service, which is actually what your code's going to be. You're going to have the configuration, which is going to be any environment variables or any other type of runtime values necessary to make your code run. And then you're going to have the route, the endpoint to be able to access that code. If any of those items get changed, you're going to get a new revision. So think of revision as a snapshot or versioning of your serverless code running, right? On the right-hand side, the next box is eventing, right? Eventing is actually still a little bit of a moving target. The APIs have not kind of solidified, but we're working on that with the Knative community. But some of the key things here are the channel, importer, aka the event source, broker. Those 3 items are probably going to be the bulk of it, and then the rest of the stuff's kind of up in there. But like I said, we'll be working with the Knative community to really nail this down sooner than later. Next slide, please. All right, so for user experience, I just want to give you guys a quick glance. There's a Knative command line available. Like I said, we'll have the ability to be able to download that right from the console as well in the near future. Next slide, please. In addition to the command line, we actually allow you today to go ahead and make some of your applications serverless right off the bat via the developer console. So if you go and you create an application via deploy image, import from Git, or essentially create any new app, there's now a serverless checkbox there. That means you'll be able to scale your application down to 0. There's a nice little video playing on the side right here that will kind of show you the workflow through that. And next slide. So here, I wanted to show you guys 2 side-by-side deployments, one done through regular Kubernetes, the other done through Knative. As you see, with Knative, it becomes easy to grab an existing deployment and move it to Knative, and now you have the added benefit of being able to scale this deployment down to 0. So it's easy to do, in most cases, it'll be easy for you to do a lift and shift to serverless. Next slide, please. All right, so one of the last slides I want to show you guys is the cloud native development cycle. As you notice, a developer goes and makes a code change here. This triggers a tech line pipeline build. Once that pipeline build is done, you'll notice on the right-hand side, a new revision is created. So we've seen a couple of technologies here. You have Che working, you have Tecton working, you have Knative serving working. And then on the right, you see network traffic. So we actually have all 3 revisions running at the same time. And we could say, hey, the West Coast, I want 10% of the traffic to go to revision 1. On the East Coast, let's have 10% go to revision 2. And then the rest could go to revision 3, and that's done via using service mesh, right? So you're able to do weighted traffic to your different revisions. So as you can see here, here's a full life cycle of multiple technologies working on top of the OpenShift platform in conjunction together. Next slide, please. All right, so we just announced OpenShift Serverless 1.0 Tech Preview 1. It was released in September of 2019 on OpenShift 4.1. It depends on OpenShift Service Mesh GA version, which was released before that. And you could get it via the OM channel Tech Preview. Next slide, please. And here's the overall serverless OpenShift serverless roadmap. As you can see, since June, we've had Dev Preview out. We just released Tech Preview 1 in September. And Tech Preview 2 is going to be coming out November, December timeframe. Some of the things to look for in that are the Tecton integration with Knative, the ability to do eventing via command line, and then one of the big ones is going to be rolling updates via OLM. So your OpenShift serverless offering will just get updated, can be automatically updated via OLM by Tech Preview 2. And then we're planning to go to GA February timeframe. By that time, the Knative eventing API should be solidified, and you'll have the ability to do Knative eventing. The developer console will support an eventing interface as well. We'll have advanced metering available, and then CamelK should be productized by then as well. Again, that's all the enterprising integrations, 200 plus as of today, available at your fingertips. Next slide, please. All right, so I'm going to hand it off now to Daniel Messer. He's one of our awesome PMs that focuses on operators. So back to you, Daniel.
Thanks, Ali. Great job. And also massive kudos to you to bringing the pod donut back in 4.2. For the viewers who don't know what that is, that's a little graphical circle display that you always had in your deployments, representing the amount of pods running behind that. So big fan of that. Thanks.
You and every developer.
Exactly. So if you haven't noticed by now, OpenShift 4 is obviously not just about donuts. It's all about operators, right? And these are not just operators that manage the cluster under the hood for you to give you that automatic day 2 operation experience and frequently updated base that Rob was explaining in the beginning. It's also those operators that we call like workloads or service operators that essentially enable admins of the cluster to turn into service providers of managed applications, right? So they enable these operators on their cluster, and then suddenly the tenants, users, and developers of these clusters can request services and applications in a managed service fashion from these operators in a self-sufficient way, right? And for that reason, OpenShift treats these operators as first-class citizens using something we call on the next slide, the operator framework. So the operator framework is a upstream open source project, actually outside of OpenShift, but obviously heavily productized and integrated in OpenShift as well, which next to the lifecycle manager, which is the central component on cluster, helping the admin to deploy, update and install operators and manage their general lifecycle. There's also tooling for the developers and a publishing platform that we call operatorhub.io. This is a community project where the Kubernetes community comes together and can share and publish the operators for easy discovery and installation using a graphical user interface. Next slide. So we have 3 main personas that we are going to service in this in the world of operators on OpenShift. First is actually off cluster, the developer who creates the operator code. So that's where the SDK helps these people to concentrate on the main business logic and not on the boilerplate code that you always need in order to interact with the Kubernetes API. And the result of that is a binary and a set of deployments that would already constitute an operator that you can install manually, right? The lifecycle manager in the next phase creates a definition of a package around that, which allows us to not only package up individual operators, but groups of them, including the entire version history and publish them in these catalogs, for instance, using Quay.io or container registries. This is also what enables the administrator on cluster to discover which operators are actually available to install, right? So the lifecycle manager, or short OLM, will basically read those catalogs of operators and present them in a nice graphical user interface for the admin to basically pick and choose what they want to enable. That process we also call creating a subscription against the operator, because it's the same nature of constant over-the-air background updates that we have for the platform itself, right? You also want not only the Kubernetes foundation to be updated and kept up to date, we also want that, for instance, for your installed MongoDB as a service or Redis as a service operator, right? So they create a subscription on the cluster, and that installs an operator into a namespace or multiple namespaces, and this is how the third persona, the users, are essentially becoming aware that there's an operator available in their little piece of the cluster, right? So they can see which operators are installed and available to them, which services they offer and how to use them, and what they eventually do, right? And this way they create, in a self-service fashion, a managed application that is eventually run by the operator. So that, in a nutshell, is how the operator framework works on an end-to-end fashion. Next slide. I mentioned OperatorHub.io as one part of the open source project Operator Framework upstream. There's also the website OperatorHub.io. We have a version of that in cluster in the OpenShift console as well, which is where the admin picks and choose operators in order to make them available on the cluster. And this is also what allows him to add additional, probably more curated catalogs of operators to be shown here. Next slide. One thing we did in 4.2 in general was enabling OpenShift to run in proxy environments. And obviously, when the platform is configured like that, also the operators need to adhere to that configuration. So in order to make an operator aware that it's running in a proxied environment, OLM detects if OpenShift is configured with a cluster proxy config object and takes that object and pushes down relevant information like the URL and connection string of that proxy down to the individual pod and deployments of the operators. So this is automatic and happens in the background and was introduced in OpenShift 4.2, which just released last week. So next slide. Also in 4.2, we automated the dependency resolution. So one aspect of the lifecycle manager is the packaging format that it uses in order to ship operators. And in this packaging format, you can actually express dependencies on other operators, right? When you develop an operator, you follow the classic Unix philosophy, do one thing and do it well. So your operator should actually do that too. And when it needs other functionality outside of its knowledge domain or area of expertise, it can express a reliance on other operators to do that, right? In this example, Jaeger and CockroachDB. So expressing that dependency was already possible in 4.1, but in 4.2, OLM will actually go out and check its own catalog or catalogs and scan for operators that can potentially fulfill this dependency. And if it finds them, it will install those automatically. So you'll notice that in 4.2, where we released, or where we now also have Service Mesh available. When you click to install OpenShift Service Mesh, it will automatically also install some of the dependence operators like Jaeger or Kiali. Next slide. Another 4.2 feature aimed at multi-tenant clusters was the ability to have non-cluster admin users install operators. By default, this is a cluster admin only operation, and there are good reasons for that. If you look close enough, operators behave very much like kernel extensions on a Linux operating system. It's very powerful, very highly privileged, and globally available. So by default, an operator is not something a regular user can install. But when an admin makes use of curated catalogs, he can essentially, in the same process, pick namespaces in which he wants users to allow installing operators. What they actually do is they create RBAC that allows a user to create subscription objects, which is the entry point to install operators through OLM. And they will also put a service account in this namespace, which OLM will recognize as the maximum amount of permission that any operator in this namespace can get. So when you give users the right to install an operator, they could potentially install an operator which comes with cluster-wide permissions, right? And if they do that in their namespace, the service account of that operator would be present in that namespace and therefore available to the user, right? So by having this additional service account in here specified by the admin that also the user cannot easily delete, you basically cap the maximum amount of permissions that any operator installed in this namespace can get. And the same thing to do, obviously, here is to rule out any cluster-wide permissions and only keep in objects and APIs that are of usefulness for an operator. On the next slide, we have a roadmap out to you. It's a fairly busy slide. I won't walk through all the things here, but for our 3 to 9 month outlook, the high-level themes for the operator framework are simplicity, especially for the lifecycle manager, simplify that interface, simplify that API surface, and make it really, really easy to ship operators. We are going to use container images for that to ship those operators and then metadata. And we also will enable the use of plain container image registries as catalogs for operators. So that obviously is something that everybody who has container tooling installed can use in order to create those. And it also allows admins to have container catalogs that are not hosted on a public registry. On the SDK side, helping the developers a little bit more, we are working upstream with the Kube Builder community. This is another somewhat more focused project of helping operator developers. The Kube Builder tooling focuses on Golang-based operators, and we are looking to support that particular project and project layout for the developer as well, including the command line switches. What we will most likely end up doing is vendoring in Kube Builder and use it under the hood. This gives us, one upstream community project that deals with Golang-based operator scaffolding, and also allows us to concentrate on some of the additional languages that we want to see in the future, like Java or Python. In general, the decision to make an operator metadata something you can ship as part of a container image also allows us to be somewhat flexible what goes inside this image. So we are also evaluating designs and architectures where an Helm packaged operator can actually be installed through OLM as well. This is a little bit further out and still under its investigation and discovery, but it's definitely something we are looking at. Switching gears real quick on the next slide, going over to OpenShift pipelines. This is actually one of the other operator-based add-ons on OpenShift that drives the developer experience. And OpenShift pipelines is based on the Tekton CD upstream open source project. So what is that about? This is about CI/CD the cloud native way. So what does this mean? It means that instead of running a dedicated, potentially external to the cluster system to do continuous build, continuous deploys into separate environments using a specific DSL to write and express the pipeline, you use OpenShift to do that, and it's Kubernetes Foundation. So with pipelines, builds run in pods, and there's no dedicated CI/CD engine to run anywhere. It's basically implemented as an operator and therefore is part of your cluster. And the pipeline operator in OpenShift provides a one-click experience to get that available to users. What it does, it abstracts the whole underlying infrastructure to pipelines away. So you have basically a task-based sequence of steps that you can model and express a pipeline with, and you can decouple any specific inputs or output from that. So you don't need to hard code things like Git repository locations or target registries where the eventual artifact will end up. This allows a nice decoupling of the pipeline and drives reusability across distributed teams that are creating applications using a microservices design. Next slide, please. So how do you use this? You consume this in the very same way you consume any Kubernetes core feature using objects, that is APIs, and our beloved YAML manifests, right? So custom resource definitions model all the user-facing aspects of pipelines. They allow you to create pipelines, run them, tail their logs, add tasks to them and configuration. And internally, this relies on Kubernetes core strengths like scheduling and running containers, which also makes this a very lean system, right? So all these aspects don't have to be reinvented because Kubernetes takes care of that already. And pipelines just layers on top of that. It also supports well-known tooling like Builder, JIP, or OpenShift source-to-image tooling to eventually produce the artifacts. And because it's not opinionated about where you actually deliver those artifacts, it can deploy in different architectures, right? So a popular use case is obviously the same Kubernetes cluster that pipeline is running on, but you could also deploy on hypervisor-based infrastructures or serverless platforms like Knative or other Kubernetes clusters, right? The developer experience on the other side allows for easy integration into existing workflows. So on the one hand, you have a powerful command line utility, or you can use UI integration in either popular editors like VS Code or Eclipse J, or even in the OpenShift UI itself. And that's going to be the developer portion of the UI that Ali presented to you earlier. On the next slide, we see an example screencast of how you would use that CLI. So TKN is a CLI that ships with pipelines. It allows you to list pipelines that have been created using YAML and also list resources that you can combine in the pipeline execution. Once you start a pipeline, you can actually follow their output and see the progress. And that obviously allows for easy automation in any kind of existing developer tooling and doesn't require the developer to be aware of any of the underpinnings, right? This is actually a tutorial that you can find on GitHub, and I provided the URL below on the slide there as well. Next slide, and last slide for me. Roadmap-wise, we have reached the developer preview stage 3, in which we delivered support for OpenShift image streams. We improved some of the RBAC and also added more commands to the Tecton CLI. We also shipped the Visual Studio Code plugin, which is really nice. And now in a 1-month cadence until the end of the year, we will ship out more releases. So Dev Preview 4 is scheduled in November and gives you GitHub webhooks and pipeline as code, as well as even more commands in the Tecton CLI. And then as a nice Christmas present, we give you actually a tech preview, which has some interesting further use cases like catalogs of tasks that make up reusable parts of pipelines, Knative use cases, obviously, and integration in Che and the developer console. And with that, I hand it back over to Rob for OpenShift Service Mesh.
All right, thank you, Daniel. Yeah, let's talk about Service Mesh. So you heard this mentioned a few times because this is kind of the network fabric that makes some of these other technologies work. When you're running your serverless functions, they need to scale up and down. You need to be able to route traffic to them, do the load shifting, as Ali was talking about. That's all powered by the OpenShift Service Mesh. Now, just like all the other projects we talked about, this is backed by a suite of open source projects, all combined together to give you a really great product experience. So the main one is Istio. You see that in the middle. That is kind of the best in breed of open source for doing service mesh type things. But we also pair it with some other things out of the box that you're going to need to be successful using a service mesh. So from the top left, you see this little guy for the Jaeger project. That is a tracing library. So as you have like an HTTP request moving through this system, you might want to do some connections between the different microservices that request is going to go through, or you might want to route it around based on a HTTP header, for example. So the Jaeger tool helps you do that. Now, when you're looking at all that, you probably want to visualize this because you might have tons of requests going through. So down on the bottom left, there's a project called Kiali, which we ship and integrate into OpenShift, which is a dashboard for looking at the different routes and network flows that you have going through the mesh. That also integrates with Prometheus and Grafana. the tried and true tech stack for running monitoring infrastructure. We've got some built-in dashboards to help you observe overall traffic moving through the cluster, keep an idea of the health of the mesh itself, capacity planning, that type of thing. This is what Kiali looks like. So right here, we're looking at some traffic that's going through several different microservices that power up this product page that we have. And as you can see, you've got colored bars for request throughput, HTTP status codes, exactly where traffic is actively being routed to, latency, and you can even dig all the way further into a bunch more information. As you can see, this would really help you as an operations team, your SREs, your developers, as they're looking at the different versions that are out in production, things that are being staged, things that are being rolled out. Here's a drill down specifically looking at the interaction between this review service and a rating service. You can see that there's actually 3 different versions of this review service that we're tracking. These could be, traditional containers in a pod from a deployment, or these could be serverless workloads as well. It doesn't matter. All integrates into the service mesh, and you can see that they're all talking to this ratings backend service, and we've got a bunch of OK requests here going through. So you can dig much deeper into error rates over time and that type of thing. You went one level deeper here. You can see the actual endpoints that are powering that review service. You can see the different IPs that you can talk to in the cluster, the endpoints of the pods themselves. And here we can see that, yes, everything is healthy. We mentioned the traffic weighting before on the serverless side. This is the service mesh feature that makes that happen. You can dial up these different versions and weight traffic. You can do this via the UI in Kiali. You can also do this programmatically if you want to integrate this into a promotion workflow that you have for your CI and CD system. There's a host of other UI-based options where you can mess with enabling or disabling TLS. The nice thing about a service mesh is it owns all the network traffic flowing through your machines, and so you can actually do automatic TLS and secure that traffic without modifying your applications. You can also add virtual load balancers and other things like that. This is what the service mesh roadmap looks like. So we are I believe the first Kubernetes offering to GA a service mesh based on Istio. And so we're have that out now. We're going to have other channels of releases, so like a long-term support channel and things like that. And we'll keep integrating and improving upon all the components that we talked about, Istio and Jaeger, Kiali, Prometheus, Grafana. For the first half of next year, we'll take in some new updates to Istio. We're going to pursue some security certifications. This is really critical for government and financial customers, but important to everybody as well. So we're going to grab FIPS 140-2 certification, some other integrations with work on the dashboards, and then some really exciting stuff around multi-cluster mesh support. So you can imagine how useful this is on a single cluster, but you're not just running 1 or 2 clusters, you might be running 10 or 20. If you want to have a multi-cluster mesh that spans a subset of those clusters, we're going to look for support for that in the beginning of next year. And then getting into the second half of next year, obviously a little bit more open. I'm sure there's a ton more detail that's going to come in here. But one thing we're looking at is additional protocol support. So, HTTP-based traffic is great, but there's a bunch of other different types of streaming data for MySQL, Mongo databases. Your Kafka streams are all super important to be routing and introspecting and tracing through your service mesh. So there'll be new features coming related to that as well. All right, I think that are all the topics we had for today. As Diane said, we've got some time for questions, and so I'll let her moderate those. Thank you all.
All right. Well, thank you guys very much. That was like the tour de force on the platform services side. There's a couple of questions in the queue, besides the ones that I asked, which got answered. So what is the status of OCP 3 to 4 migration tooling? Dale is asking that question.
All right, I can take this one. So we have a migration tool that we are working on and testing with customers right now. And this is important because you're going to want to do like a side-by-side, like a blue-green type deployment for moving from OpenShift 3 to 4. Now, what this tool is going to do is once you stand up the infrastructure side by side, is help you on a per namespace basis or across the entire cluster pull over different applications. And so that's all of the namespaces, services, deployments, and RBAC and that type of thing, as well as the backing volumes. Now, the volumes are key because this is where your data is. Data gravity is a real thing. So we've got 3 different modes of doing that, which are pretty smart. If you're on a cloud provider where we can swing your PVs from like one node to another, we'll just do that between clusters, and so you don't have to copy any data. If we we will do some migrations of that data without swinging those PVs, but in a more sped up fashion. And then lastly, if you just have to copy the data, that's the most tried and true method. We've got some tools that'll help orchestrate moving from one PV to another. So if you need to move from like a cloud environment to on-prem to an NFS cluster, for example, you can manually copy that data as well. That's all driven by a UI that cluster admins can use to, move one team over at a time or move from this cluster to that cluster one at a time.
All right. Hopefully that answered Dale's question. Novanil has got another great question. Does Kiali take care of egress traffic too, or is it just all ingress and all comms within this cluster?
That is a great question. I believe it handles bidirectional traffic because it's looking at, if you think about traffic going into one system is really leaving another. But I don't know exactly the features in Kiali that are optimized for that. I know it is very much ingress visualization, but I have to imagine that it does a lot of egress as well.
If you want follow-up, just pop it in the chat, and I'll even open it up for if you want to ask questions. Maybe Daniel, you could paraphrase what FreeArc is asking in there's like a whole series of questions, and I think those would be good ones to air. They're around the console customization possibilities with CRDs.
Yeah, I think they're actually meant to be 3 separate questions. And the first 2 are for Ali. I'm just going to comment on the last one, which was actually directed at me, on where to find documentation on the procedure in order to allow regular non-cluster admin users to install operators. And I've actually pasted the link in the chat. It's in the official OpenShift documentation under operators, and there's a whole part about how to add operators to a cluster in general, and then the delegation to a user is under the section about creating a policy for operator installation.
All right, now I will pull that URL out and add it in with the posting of the YouTube on the blog channel as well. So yes, Ali, those other ones now I see are for you.
Yeah.
How about you go for it?
The first question is asking about, we actually created a nice little blog about console CRDs and the console customizations and how to take advantage of that. I did not mention anything about the branding because it wasn't using CRDs, that we're actually using config map. I could find the documentation for that and add it, either email to you or add it to this if I find it quick enough. How to update the branding. And then the second question is, the declared dynamic UI is a more powerful, flexible replacement of the catalog template forms in the old web console. So, sort of, like, right now when you go and you create a service that's provided by an operator, we go straight to the YAML. This is actually allowing you to get that form interface. So yeah, it's a close replacement, I would say. The templates had more stuff with like app binding and all that kind of other stuff that was involved that we don't do right now. But this does give you the ability to have a nice form interface, guided interface to create resources versus just getting thrown into YAML editor.
All right. I'm not seeing any more. Oh, here comes another one. Gaurav is asking, okay, console external log links CRD. Is that cluster scope or namespace scope? You're getting deep wormhole here. Go for it.
Cluster scope.
Know the answer? Cluster scope. There we go. This feels like Trivial Pursuit with some of these. And anyone else got questions? We've got these guys around for the next 5 minutes or so. Take advantage of it.
By the way,
Otherwise,
if anybody wants to try out any of the CRDs for this, you could go to try.openshift.com right now, download the interface. There is under administration, there is a custom resource definition navigation item. You go in there and just type in console to see all the console related CRDs, and you'll see console external log links, notifications, and all the other ones there. And there's examples right there. There's a default one in there, so you go ahead and just click create to see how it works, and you'll be able to see all the different values that you could enter. And we have a really nice schema side panel that'll show you the different possible values as well. So take advantage of that. One other thing I want to mention is we're having one of our first customer empathy workshops at the next Commons event in San Francisco on October 28th. We'd love to have you guys be involved and be part of it. There'll be an opportunity to work with the OpenShift UXD team, PMs, and engineering. And the topic around the first one we're having is going to be troubleshooting on OpenShift. So my little pitch right there.
awesome. And I'll put the link for that into the notes too as well. The UX design team is always hosting workshops looking for feedback and to do that stuff. It's not like they don't have empathy. They have tons of empathy, and they want more of it. So to be around in the world. So this would be good. There's a couple more questions coming in. We still have some time. Dale is asking if we have developed templates in OCP3 catalog, will those be directly applicable and exposable in 4?
Yes. So in the console, if you go to the developer side, if you go to add project, there's actually one of the cards. It says developer catalog. You can expose your templates that way. We still have the developer catalog.
Gaurav is asking a question. Is that on the roadmap per namespace configuration of external logging targets? I think that's a follow-up to his previous question.
Oh, not yet, but if you want to send me, if you want to elaborate more on what your exact use case is for are you guys using multiple external logging solutions for different projects on the same cluster?
Multi-tenant needs is what he's saying.
Okay.
Well, maybe what we can do is put you in contact with Ali and other folks.
Definitely. I'd love to dig deeper into this and see something we could do to help you.
All right, Rob, I think I heard you. Maybe we should wrap up a little bit here. If there's anything else people have questions on, please feel free to email us and reach out. We can connect you with the right people as well. I'll post this video up on openshift.com/blog or blog.openshift.com, whichever way you come to that site, as well as onto the RH OpenShift YouTube playlist. Probably by tomorrow it'll be up there. And we will be doing a follow-up on the infrastructure side of this the week of November 6th and 7th. So look for that as well. Do you have any final words of wisdom, Rob, Daniel, Ali?
I was just going to throw one more plug out for come chat with us at KubeCon if you're going to be there. We've got OpenShift Commons Day, but we'll all be around. We've got a number of Red Hatters speaking about all kinds of topics, and we'd love to talk to you.
Yeah. If you haven't registered yet for the OpenShift Commons Day at KubeCon North America, go to commons.openshift.org and follow the navigation down the gathering menu path. We've rented a boat, a big, huge yacht that will be tied up to the dock. We're not going out on the bay, so there'll be no seasickness, and it seats 540 people, and it's filling up fast, and we will get talks of deep dives into what's coming in OpenShift 4 with folks like Rob and Daniel won't be there, but a few, Ellie and a few others will be there, as well as Clayton and the engineers will be giving some deep dives on what's coming in Kubernetes, as well as lots of customer case studies. So again, that'll be November 18th in San Diego on day 0 of KubeCon North America. So I hope we can all meet you there.
One more thing to add to that is we're actually going to be throwing our second workshop at KubeCon, and the topic of that one will be multi-cluster management and GitOps. If you have any interest in those and want to do an interactive session again with PM, UXD, and engineering, we'd love to have you.
All right. Well, thank you guys for doing this. I'll post it as soon as I can and send a note out to the Commons mailing list when it's up, and we'll just keep pushing this content out. It's a bit of a fire hose, and we really appreciate you coming in and talking and asking questions. So thanks again, everybody, for your questions. Great to see you here. Take care.
Thanks, guys. Bye.